Oops. Thank you very much for having me here, the odd bird in the room, obviously not being a naval architect. So what I like to do is put a little bit of an operational perspective to it and look at some of the risk assessment that I've been a part of now some time ago. It's now gone some time, and the NDAs that were signed back in the days, I can show you something that back in those days we couldn't show, because so I think that I've brought on something that we generally don't see is actually the projects that never happened. And that can sometimes be interesting to see what was the showstoppers of those projects, and looking forward, how do we decide not to wind up there again. So short introduction, do a little bit on risk assessment and see what actually did fly and why did that fly, although that was maybe something that wasn't straightforward in the first place. So hope this can be attractive. Yeah, LOC is a group of companies worldwide, and I sit in this shipping side of it. We have oil and gas and renewables as well. So you already said this is getting increasingly attractive to use LNG as a fuel. I started almost now 10 years ago with LNG as a marine fuel, moving back to Sweden from Qatar and Angola, doing large-scale LNG there. And first thing was I had to go to South Korea and do a project there. So that was very interesting. So it's been, and I did that for 5 years. It was a very, very interesting thing. And now seeing the presentations that I gave a long time now, 9 years ago, we just hoped to get there, and now we're there. So the kind of lots of the obstructions back in the days have now gone. I'm not saying they're all over, but we are getting there where there is an infrastructure built up. So the next phase is then to start building ships to actually use this fuel. I don't know what's been said today, but I think that just a little bit on what is LNG. It's majority for all purpose, it is methane, and it's obviously cooled down LNG down to minus 162 degrees, and then we get 600 less volume than we have for the gas. It is difficult to self-ignite, and ignitable period of time, so making it is not that hazardous as we may think. It's still very hazardous, but not maybe in the spectrum of our. In the lunchtime here we discussed hydrogen, which is on a completely different scale. So, and what can happen? I would say that the incidents that I've heard of mostly been connected to that it's very, very cold. I haven't heard so much of all the big bangs, nothing really, but the cryogenics burns on persons, and actually cryogenic problems with steel. I have heard about the incidents that have happened. So we shouldn't forget that it is minus 162 degrees. It is very, very cold. And obviously it can explode and all sorts of bad things will happen with the gas. And that just further enhances that. But we must also see that there needs to be somewhere where we can explode, and doesn't necessarily, just because we have a leak, doesn't need that we burn or explode or so on. And generally, explosions isn't what we're going to see. It's rapid burning probably is what we're going to see if we see a big thing. Then just quickly what it is. I know some of it has been said. There's two types of engines. There is the dual fuel engines, which use the diesel principle, where we have a diesel a pilot fuse to make sure that we ignite the gas. We have the single fuel gas engines. I'm not sure, but I still think it's only one engine manufacturer that do them. So it's mainly this that is installed, but actually one of the examples that I will be giving are using a single fuel engine. Tanks is a whole concept by itself. So what to do? First of all, type C or type A or B is probably going to bother a lot of people around doing that. Most of today's world, and almost singularly, is type C, because it's so much easier to operate. You kind of operationally take away a lot of hazards. So if we're going to put in a type A or B tank, which can't withstand pressure in the same way as a type C tank, we have to build a lot of other things to it, both an operational type, and we also do it mechanically difficult. Not saying that it has its massive advantages because of space and so on, but it have operational downsides that you have to mitigate in all sorts of ways. So most of what we will see, and what probably people will try to do, is using type C tanks. And since they're spacious, we have to look everywhere to find and space them. And the latest thing that I found out is this cement carrier, which have it in the forecast. You can't even see that this is an LNG fueled ship. But I mean, then you have to, how do we get to that point where that is then allowable and acceptable to have a tank like that, and still apply IMO regulations on integrity and so on? Because if we're going to hit something, it's probably over there. But having said that, we need, when we are moving forward and looking at, because we have to place these tanks somewhere, it is innovative thinking, but that also giving challenges when we do that. So it's something to think about when we move forward. And I think we saw the AIDA cruises that had somewhere hidden away as well. So they all do their challenges of where we put them. And also for bunkering, we'll see later on. Essential risk control measures, and I think this was touched on the one of the previous one, is how are you compatible? How do you make a compatible study? And these are some of the techniques that can be used, but they have to be obviously compatible on both ends. So what kind of communication link do we have to have ESD? And do we need one at all? Some of the installations that I've seen not even have a communication link. And the safe breakaway couplings, which are these, you pull it apart, the gas flows, and that's obviously a solution, but depends on the speed of what you pump on and so on, and stop the pumps. Or do we have a pneumatic system that disconnects? And when we connect, do we want dry connection, or do we want the old school system where we have bolts? These are quite nice systems, but they need to be connectable. How do we make the system work together between the bunkered ship and the bunker ship? The bunkering process is actually not that dissimilar from bunkering oil. This is moving a liquid from one point to another. So in its essential basis, if you look at this, it's not much different from what you would do if you bunker heavy fuel oil. So there is the ESD link, and we have something called cool down up here, which we need to do. But apart from that, the operational part of it is actually not that difficult or high tech. So from that point of view, it's not that very, very hard. But since it is coal and it's gas, we have to be very careful in what we do. Again, very simplistic system. One of the systems I'll show today actually don't have the vapor return hose at all. They are using the Type C tanks, and with that, they actually make sure that they take care of that increase of pressure within each of the systems. So it depends on the situation and what you do for. But I mean, if we don't have a system that take care of that, again, both ends of the system must be able to do that. I know this was mentioned before as well, and the whole thing of something going ahead is to make sure that the safety zone around here is where we cannot get to do. And what kind of credible scenario for a worst case scenario can we do? And generally that is horse rapture. The hose rupture is generally the scenario which is what makes something not go where we want it to do, and how quick we can stop the pumping and the valves and so on is generally what makes something of a risk assessment not going to happen. If we can get that down one way or the other, the scenario with that, then we can usually go ahead and make an LNG fuel in fairly many occasions actually. And I think we mentioned a little bit of infrastructure, and I think from one point of view, if we're going to move around from a large LNG terminal, we load it onto a feeder terminal, we move that feeder ship into a small terminal, we bunker a small bunker terminal and move it that way. We started up in minus 162 degrees up there, and then we move this LNG around. What is that when we're going to bunker up there? I heard something before, but it's not going to be 162 degrees. That's not going to happen. That's in the dream world. So we have to mitigate against that we have warm LNG that we are bunkering up there. I have seen figures around minus 140, minus 142 degrees being bunkered. And if you don't have that way of actually being able to do that, you have to either have a different infrastructure system, a way to cool it, and then that costs a lot of money. So that's something that you have to mitigate, because this whole chain, it's only thermoses that we are moving around and handling this cold thing in this infrastructure that will affect the commodity that we are transporting and moving in. So we have to take that challenge on. What will the temperature be when we pump it on board? That's a big challenge, and these may be very, very far away between these. So what does that give us when we then go on board and actually do a risk assessment? You probably can see where I was. There was this passenger ferry somewhere in Scandinavia, in a non-named port, that usually bunkered the ship with a truck. And this went very well. Actually, before I came on board, they had a small incident. There was a leakage, but in general terms, they had done lots of bunkering there without incidents. But they wanted to start bunkering by a bunker ship instead, because this bunker truck had to go very, very far to get there. It was a challenge by itself. So that was the reason. The supplier then had sourced a ship that was supposed to be done and come into the unnamed port, which some of you recognize, bunker the ship, go out again, and that was happy days, because the ship was already done. It's been running like this for a year when we got involved. However, the bunker ship wasn't a dedicated bunker ship. She was transporting LNG, but she was actually not being used and designed to do bunkering LNG. She was pumping LNG all over the place, but she was very big for the ship that we're not talking about. And since the ship wasn't designed for this, things were sticking out all over. This is actually the bunker port sticking out down there, and with a bridge that's sticking up all the way to the side, and no available fenders that could actually push the ship outside. That proved to be a showstopper. It just could not be done at the point. And even if we had very big fenders, it would require very small angle of heel before you're actually starting to hit this one. And again, if we would have dropped this one on the hose rupture scenario that I discussed earlier, we just could not make that out, because if we dropped that one down, that would go. And then our scenario was, couldn't do. Another thing which we possibly could have done also, the mooring capacity. There was no way to moor this ship. We would have to run mooring lines all the way forward and all the way back. She was not designed for this. So I don't know. I think possibly they've done something on her later, but at that time in place, that never went ahead. So this project was cancelled. And just out of curiosity, when we talk about this, that they need to work together, and just to say, ESD system is this emergency shutdown system. Emergency shutdown 1 is when you stop your pumps. Emergency shutdown. ESD 2 is when you actually disconnect the hose. And without going into details, that this was different between the ship, the bunker ship, and the bunkered ship. And I mean, you can make these two fly together, but at the time where we were, they weren't. And how do you do? Which one do you then design the final system? And if you do influence one, how do that? That's actually your integral system that you have designed your ship on. Are we now going to inflect that on mine? And what happens then this is kind of a kick-on effect when we start that. So this thing, when you do that, it is difficult because, as you said earlier here, this compatibility between the two systems, they need to fly. Trap volume is a whole system by itself. When you disconnect hoses and you get something, and warm LNG stays in a hose and then expands 600 times, and that can be all nasty things that happen that need to resolve. But we leave that for now, for some other dates. The next system that never flew was a very specialized Ro-Ro carrier. And to my knowledge, she was built without being LNG fueled. The plan was it isn't this ship, but it looks very much like the plan that we were involved in. It was a bunker put somewhere here. The inlets for all auxiliary engines and everything was up here. There was loading going on there, and she was supposed to be bunkered by a truck from the shore side. And as you can see, she was running an auxiliary engine just above where we were. Trucks running around the whole place where this happened, and we could not get this to work with any sort of credibility. And I think that everyone involved could see that in the end, but I don't know why they decided to have this ship and why they couldn't turn around some of the points where were pointed out, but they decided not to in the end. So this never flew. I think they do have some new build ship, but as I said, they're not with LNG. So what happened if we then go into talking of something really difficult? What happens to an LNG fuel ship if something really bad happens? And if this fuel system isn't directly affected, it still have problems because at some point it needs to vent. At some point the 7 bars of the Type C tanks will have to be vented. And if you are stranded somewhere and it's a blackout in the ship, it imposes a lot of different tasks to what to do and what to do with that. So without going into too much of the problems that it is, make a quick risk assessment what you're having at hand if there is LNG on board, because you possibly have to do something relatively quick. You may have a number of days, but not much more, before this is going to be a major problem. So act quick, is that what we can say? So it's not always bad, is it? This is a very, very odd setup. This is the first LNG fueled passenger ferry in the world, Viking Grey. She's been running for years and years now, and the infrastructure around bringing this LNG to her is actually a little bit of what I described earlier, the worst case scenario. This is a medium storage tank of LNG that is being fueled from Europe. Then it's taken by truck up to Stockholm, loaded up to Seagas, and then filled up on the ferry. There is a long story of why that happened, and it is still today a kind of an interim solution where Aga, who was the gas supplier, is also owning this. They want to have this bigger infrastructure, but they only got one customer when they started out. And to then build a bunker ship purely for her was too difficult. And getting that one in and out of Stockholm, which was possible, she can go out here, but it's a journey of almost 4 hours. And in the winter time, it's ice out there, so they decided not to go for that. So they're driving and still do that. And they still hope that they will have more customers where they can put Seagas into retirement and so on. I was involved in this from the very beginning, and what they do is they actually have passenger handling on the other side. They load and discharge at the ramp, but what is important here, there's nothing overhanging on this side. This can be completely sealed off area, everything in this ship around the inclusion zone of 25 meters from where the bunker board is cleared off. So you could manage that kind of area to do. This actually worked very well, and I think today she's possibly done 1,500 bunkering or something like that, once every day. Just quickly show a little video.
Ja, vi befinner oss på bunkerfartyget Seagas på väg bort nu på morgonen här till Stadsgården för att fylla upp MS Viking Grace. Seagas är världens första bunkerfartyg för flytande naturgas och det är också världens minsta fartyg för flytande naturgas. Fartyget är också byggt efter precis samma regler som stora LNG-tankfartyg som opererar ute på världshaven. Det här fartyget Seagas får sin LNG borta på Loudden där vi precis avgick ifrån. Och där fylls den upp 3 gånger med 3 stycken tankbilar varje dag. Och sen seglar vi bort till Stadsgården 1 gång om dagen och där sker den här bunkringsoperationen. Och det här är en väldigt snabb operation. Man kan likna det med ett Formel 1 pitstop i ett shipping-sammanhang här. Där de har bara 1 timme på sig vid Stadsgården. Och det här är en väldigt unik lösning att kunna göra på det här sättet. Skillnaden mellan naturgas och LNG är att LNG är flytande jord. Man har gjort naturgasen flytande genom att kyla ner den till minus 160 grader. Och när man gör det så minskar också volymen på gasen med 600 gånger. Vilket gör att det här blir ett väldigt energieffektivt sätt att transportera gasen på. Ja, då har vi precis kastat loss här nu från Viking Grace här borta på Stadsgården och avslutat hela bunkringsoperationen. Och samtidigt här nu så återställer besättningen fartyget efter bunkringen och förbereder samtidigt för att kunna ta emot LNG.
So, when you design a ship out there, it may not be the scenario that you designed the ship for that actually will be used in the future. So, even if you're not designing for that, so look at the first thing is it wasn't designed for or fueling with a ship, but in the end they wanted to do something else, and then that was proven difficult. So it is very important when you make the designs out there that they are proven to be for the situation that is, and if not, try to come up with an alternate solution. It's usually possible. I mean, the situation of the Viking Grace, so doing that in an hour's time, is challenging, but it worked. But it only worked because they actually started it. I was in Turku in Åbo before all the keel was laid. That's how early this was. And the bunker supply was involved from the very, very beginning. That's the only way where that flowed. Otherwise, I think that would have been a very challenging task. And I think I said compatibility studies. So that's me.